productive human ecology means that we're upcycling energy to some other living system that's also kind of giving back what it has absorbed and cycling in within the natural systems of the planet. In contrast, a non-productive human ecology would be something that then starts to create a bunch of negative impacts within the ecosystem. So that could be reduction of oxygen in aquatic or marine environments. That could be acidification of the ocean. Those are all impacts of like our behavior as humans. What we need to do is figure out how we're not impacting those other trophic systems because they provide critical ecological services to us.
Before we go into the podcast, if you could just go and rate this show on whichever platform you're listening to it, it makes a huge difference to the podcast, the amazing conversations we get to have, and the incredible guests we're able to get on the podcast. So it's probably not something you would think about, but if you could just go rate the show, follow it, or share an episode, it does make a huge difference to the show. Thank you so much. In a world increasingly facing the challenges of climate change, with the Building Green podcast, we will dive deep into the intersection of architecture, design, urbanism, and environmental responsibility. I'm Ladina Schipp, your host. I've been an architect and building site manager for the past 10 years. During my studies at ETH in Switzerland, as well as in my working environment, I've had many touchpoints with sustainability, like many of you, I guess. I've also learned to question what I've been told, which is why I decided to go deeper into the topic and uncover what sustainability actually means. My mission is to highlight the transformative power of sustainable architecture, not just as a practice, but as a catalyst for broader societal change. Subscribe for more of our content and enjoy the show. Today's guest is Scott Bishop, founder of Bishop Land Design and a true pioneer in landscape architecture. Scott describes his work as applied human ecology, a concept rooted in understanding how humans can create productive, symbiotic relationships with nature. In this conversation, we'll explore why green roofs are so important, how microforests and de-lawning can actually revolutionize biodiversity, and the overlooked magic happening beneath our feet, in the soil. Scott's enthusiasm for creating functional ecosystems is contagious, and I promise you'll leave this conversation inspired to look at your surroundings in an entirely different way. Scott, let's start at the very beginning. What's your story and how did you get into landscape architecture? And what was like the first moment that made you care about sustainability and human ecology?
Oh, that's a good one. So I really, I grew up outside of, let's say, urban Grand Rapids, Michigan, was very interested in what was happening around me. These were different times. So, I would just wander around in what was the woodland in our backyard, and I would see the streams that then connected to, again, all kind of in secondary forests, but, places that at that point were almost 100 years old since they had been harvested, and just being in the woods, using that as my playground, whether I was like trying to divert the stream, but also just following that stream down to where it would eventually end up, which was the Grand River. And for me, that was part of, how I grew up, was being in nature, being in the woods, and then trying to understand how all those systems worked. So I had an early interest in biology and how, again, all things kind of started working together. The interesting thing about that was, later on in high school, you saw, all right, biology starts to kind of siphon you into something. What do you want to do? Physiology? Do you want to do marine biology? And for a while, I actually thought I wanted to do marine biology. So I went to College of the Atlantic, which had a pretty good marine biology department, but also had a lot of interactions, like trying to figure out and map marine mammals. And so I was like, that's where I want to go. When I got there, then I realized that what I really wanted to do was not to get more and more specific in life. What I wanted to do is to be more and more general about the living things that we interacted with. So College of the Atlantic, great place. Would definitely recommend it for people that want to start out from a generalist position and kind of understand where we are on the planet. And that's my first degree as a human ecologist. And human ecology is trying to understand how humans fit into their environment. So we're kind of like studying ourselves, same way we would study everything else, because we're not outside of every other living thing, right? We're actually related to every living thing. And what I do at Bishop Land Design is try to think about how we create productive human ecological relationships, because human ecology is human ecology. What has happened and transpired over the past, 10,000 years is like what humans have done to change and alter the planet. And that's kind of what we are, right? Like that's what we do. So we can start to influence that now with like our understanding. We're like all globally connected. Hopefully, I don't know how many viewers do you have, Azina, like 10 million, hopefully. But either way, like anyone hearing this message makes you start to think about how we can start to influence things on planet Earth in a positive way versus a negative way. And we have had a big impact on the planet. And we want to realize, we want to use our intelligence. So Homo sapiens means the knowing ones. That's what we named ourselves in terms of a species. So I believe in that. I think that we should be the knowing ones, and we should use our big brains to actually solve the problems, a bunch of which we created, honestly, and some of which we don't create, and use that to solve the world's problems. We could also just be like bacteria, and we are in an enclosed system. Planet Earth is enclosed, except for a few rocks that we throw in space, a few satellites, and a few things that come in at us that can be super dangerous. But honestly, we need to kind of take care of the bubble that we're in. Otherwise, we're going to be the same as a bacteria. We're not going to be smart. We're going to be the same as bacteria, and not to be crude, but in a petri dish with enough food, they shit themselves to death, right? With their pollution. They make their own pollution, and then they create their own demise. And I think everyone can kind of see that that's the situation that we're in right now. We're getting close to that. Like, do we want to be bacteria? Do we want to be smart monkeys? You can choose. And so really what I think about landscape architecture is that we are applied human ecologists. So we have a bunch of tools that we can use that are going to get us to that point of creating productive human ecologies. We've touched everything on the planet. It's either by some really nefarious chemicals, but just by the amount of carbon dioxide that we've put into the atmosphere, we've influenced what's happening on the planet. And that's why certain people have classified this as the Anthropocene, right? So we're in the era where like humans have had big impacts. If we look at the function of the ocean, we look at the function of the atmosphere, we look at the function of the terrestrial environment, all of those things have been dramatically influenced by our occupation. And so we actually want to try to figure it out, right? I like people. That's kind of why I'm into this. I like thinking about the big picture. I want to believe that we're going to be able to figure this out. We figured out really interesting things before at a global scale. And, I think a lot of the media feeds us to start to believe that there's no hope, and I don't want to be there. I want to be at the point where we think about how we actually get to the point of change, where we actually fixed it. There's a really good example of this, which is the fact that we started to kill the ozone layer. And we realized that. And then all of us got together as a world. And we said, we should probably not put that chemical in the atmosphere because we are going to start to really damage the environment and a lot of people that live in the polar environments. And consecutively into Australia, the north, and all of the places in the northern hemisphere that were going to be impacted by that. And you know what? We started to change that. So realize that we can actually do that. Like, that's the same thing. That's an emission that we changed and we fixed. And that's kind of where I start out with, like, let's just do this.
That's a great introduction, Scott. So then you founded BLD, Bishop Land Design, in 2016. And what's your company's mission in like one sentence?
So it's that optimistic principle that we can make the world a better place. Everything that I just said before kind of distilled down to that point. That's where we want to approach a lot of the problems that we have and how we want to basically start to interact with the landscape. And there have been certainly a lot of folks that are also on that same mission that I think, gives us hope. There are other folks that are maybe not on that same mission, but we hope that as we kind of gain momentum and understanding that optimism is what actually drives the day.
So, Scott, landscape architects are like the only designers who work with living systems. What's one misconception people have about these systems? Or what's one thing you wish more people understood about how humans can positively interact with nature?
Right. We're the ones that are kind of saying, all right, there's this environment and that environment. Various other folks interact with that living systems environments. But what we hope to convey to folks is that the power there is actually in the world that we are living in now. So whether that's nature-based solutions to resiliency, or whether or not that is trying to sequester carbon dioxide, all of those things are things that we do as landscape architects in every one of our projects. What we're also trying to do is, at the same time, figure out what our impact is and how we can reduce that impact so what we're doing is actually a net positive gain.
So I want to know more about the term you've used before, productive human ecology. Can you explain what that means, like in very simple terms, and why it's so important to the way you approach your work?
Productive means that we're actually giving something out to other ecosystems, right? Other ecosystem services, other ecosystem providers, rather than being damaging to what that is. So again, simple terms, sometimes difficult for me. Trophic energy, right, is something that's embodied in an organism and then moves up to the next organism when it's kind of either eaten or dispersed, and that energy is upcycled. So productive human ecology means that we're upcycling energy to some other living system that's also kind of giving back what it has absorbed and cycling in within the natural systems of the planet. Let's say, in contrast, a non-productive human ecology would be something that then starts to create a bunch of negative impacts within the ecosystem. So that could be the reduction of oxygen in aquatic or marine environments. That could be acidification of the ocean. Those are all impacts of like our behavior as humans. And so what we need to do is figure out how we're going to kind of do what we're going to do. that's been defined by, I think, several millennia. What we need to do is figure out how we're not impacting those other trophic systems, because they provide critical ecological services to us. All right, simple fact here. If you like oxygen, you should like trees. I like oxygen personally. I think it's great. I breathe it every day.
Same here.
Same, right. So if we can, right, those are like pretty simple things, but we need to understand that if we're going to impact the ocean's ability to create oxygen and the terrestrial environment to create oxygen, then that ecosystem service would need to be provided by some other thing that we design or engineer, which will also probably impact the overall system. We have never been able to catch up with the ecological productivity of the planet with any sort of technological advance. All of the carbon sequestration that we're doing in the terrestrial and marine environment, that's happening because of systems that have been set up over the lifespan of our planet. And if we start to impact those, we need to rethink what we're doing, because you know how much those cost? They cost zero to harm, but to replace, not enough money in the world. So we should be actually supporting those with investments and making sure that we're, again, creating productive human ecological interactions. Those ecological services are irreplaceable.
What are some specific actions we could take?
What we do is create landscapes that provide those ecological services because we design with the living systems. And what we try to do is figure out a broad range of ways that we interact with the built environment, which is pretty unique. So what are the things that are really important when we think about like carbon sequestration? Everybody kind of thinks about a tree. Some people that may have some more advanced thinking kind of understand that there's something going on in the ocean that makes oxygen. And it's not just those nodules on the bottom. It's actually this whole digestive process that is created there. But if we use nature-based solutions to fix resiliency issues, as well as how we interact when we design things and the terrestrial and near terrestrial and marine interface, then we're making sure that life can inhabit those things. And those living things are providing those ecological services. And that may not be as simply put as you wanted it, but just imagine every time we add in more things, right? This is the biodiversity issue. Every time we add in more living things, there's more interactions in terms of how that productive ecological system can recreate itself.
Could that be things like mangroves or something like that?
Huge mangrove fan. You can see some of the writing that I've done in the past. It was very early. I was very early on the mangrove scene, but I also like collect some of them sometimes. They're not in this space, but in the other part of my office, and I'm very far up north. Very interesting that, right, these things work to create an ecosystem, and that's the other thing that we look at doing. So finding a structural keystone species, a mangrove is one of those. So it's providing this kind of overarching structure that's reducing wave attenuation. It is providing habitat for little fish and little corals and all of it. It's a nursery, and it's regenerating itself as it's doing that. Like, we play very little role in that. And it is just kind of building on itself as it becomes a topographic generator. So mangroves are a very good example. Thanks for bringing that up. Other ways of doing this are really like how do we actually, in an urban environment, start to reboot some of those ecological processes? And you got to go deep, and you got to look into the soils. There's a whole world down in the soil structure that often when we think about construction, you're like, dig it out and then like put some back. that's not really how it works. There's a bunch of other things that are happening. So as landscape architects, we think about soil structure. We think about the inhabitants, the things that are going to live in that soil, and how they, again, correspond to the relationship of that structure that we're putting into the ground. And that's where a lot of the carbon is. It's kind of between the trees and in the ground. And honestly, we haven't really quite figured that out. It's really complicated how respiration works between that. But we do know, and if I'm sure many of your listeners have seen some really fascinating commentary on how trees interact, how they kind of start to talk to each other. And so that is, that's in kind of how a lot of us are starting to think about what we can do in the landscape. It's not just like stick. It's actually, how is it that we start to create a communicative environment within the soil structure and within the trees, so that kind of carbon exchange, oxygen exchange really is enhanced. So it's not about planting a bunch of trees. It's about creating a full service ecosystem.
Tell me more about that, because as an architect, it's often easy to just on your plans take out the earth, put in new earth. I always struggle as well with we always had to hand in like landscape architecture plans to get the permits. And I would always get a landscape architect, just put on some plans that they know that work together. But what do I really need to focus on when choosing the right plans and kind of the right soil structure?
Sure. So in the urban environment, what we want to do is, it's already been kind of manipulated in a lot of ways. And so we talk a lot about, and I've designed certainly roof gardens and green roofs, and depending on what climate you're in, you can really take advantage of vertical greening as an opportunity. Some of the things that you want to look at when you create those structures are, what does this mean for the other things that are here? Because if we create kind of the right conditions, then all of the friends of that ecosystem are going to come back. If you use non-native plant material, then it's likely that you're not going to find the right visitors to that place. The soil structure can be complicated, but what we need to do in urban environments is usually reduce compaction, try to figure out how we can keep it from being compacted by urban uses. And there are a series, and I won't name them specifically, but there's a series of ways to do this. You can either do that with the soil matrix, with sand or glass, or you can do that with some of these basically kind of basket structures that keep the soil from being compacted. But we want to let two things happen: increase the kind of variety that you have. There are a lot of things that do probably the visual thing, like create a bunch of green growing up on your building. But there's other things that are going to provide more ecosystem services. And so you might have that one still, because like that's part of your goal, but you might have a series of other things. So like increasing the number of species by, 2 or 3 species that are native are going to help you get to where you want to be, because there's already critters and things that, again, are part of this process of trophic process of upcycling energy. So that's great. Good. They fly away, they do their own thing. They're helping spread all of those plants to other places. And at the same time, there is always that kind of like, how is it that this thing is going to be functional and work with the built environment? The more we can make the built environment kind of reflect that kind of increase in biodiversity, the more visitors and the more kind of interesting that environment will become. Because it's not just about like people it's going to be about people and the other things, and that's going to kind of ensure that there's interest in other things happening. And I think the other big component is we're always kind of looking up and then down, is that what that enhances in terms of soil structure for the urban environment. And within the urban environment, those plants are doing quite a service by just respirating. They're going to take up stormwater. Like if you're in Miami, you're going to have a lot of rain. If those plants are adjusted to that environment, they're actually going to be part of that transpiration system. And they're going to start to pull all that stormwater out of that soil area, even if it's really limited. And then they're going to put that back up in the atmosphere. That's good. We like that. And then they're going to make sure that you're reducing the amount of runoff that you're having. And the microbes that are down there are going to be like, all right, I'm going to take care of some of the pollution that's involved with that as well. So just kind of making sure that you can think of it, again, not just as like a stick in the ground. There's the soil, there's the rhizosphere, which we call it. And then there's really the projection of the plant matter itself, and depending on what you're trying to do. And those are like the two components that are really critical kind of in that ecological system.
That's so cool. And if we're talking about biodiversity, what are some unique approaches you've used for increasing biodiversity in different regions?
So I would say there's a lot of information that is available in kind of national databases. So the EPA actually creates a whole subset of maps that talk about these different ecological zones that exist in any state. And then they'll tell you about which one of those ecotypes, like what kind of plants live there. So we did a project in Fargo, North Dakota, which is called the Ecological Stormwater Guidebook, but it's really a great tool for developers, stormwater engineers, and landscape architects or architects to figure out, like, what could you do in what would be a normative kind of retention basin, which is one of the things that they have to do in North Dakota because they're basically in a giant floodplain. So we looked at all of those different ecotypes, and then we started to sort the plant material that could live within those places. And then we compared them to urban conditions or suburban conditions and saw how they kind of could work together. Summarily, we figured out like what people could do in those things. So let's say like a sandy, rocky outcropping might be a really good place to have a beach and kind of hang out, versus what might be a mucky and kind of rich in like plant matter material, which maybe we would want to have a series of boardwalks. So kind of just creating a series of types that are related to those different ecotypes was a way that we started to navigate a way for developers, engineers, and landscape architects to have a really good discussion about what they could do, which is different than just creating a bowl of water. And that helps people, right? Because you're going to basically say, oh, I can do a bunch of cool stuff. That increases property value because you actually have amenities in that place. And that helps to fix, again, some of these ecological services issues and reflects the conditions that are in that place. So research is a really good way to figure out what to do. But the more you do it, the more you kind of find the sources that are really available to start that thinking. And then, again, creating different tools for developers and for architects, landscape architects, engineers, helps to situate that place in kind of where it needs to be.
So interesting. Whoever I speak to on the podcast, whether it's like an architect or an urbanist or landscape architect, everybody talks about the importance of just looking at the context, looking at what's there, and work with that, because that's probably going to be the best resource.
Yeah, I talk a lot about not trying to force something to be something that it doesn't want to be. when we're in a floodplain or we're in a coastal environment and people want to, they're like, let's put a bunch of ball fields there. And I'm like, you can, but it's not what it wants to be. So you're going to find yourself kind of consistently against the way that the world is working. Why don't we make it what it wants to be and then figure out what we can start to insert into that environment so that we're both learning about the situation that you're in, but also having these really unique experiences if you're in an urban environment where you're kind of learning and through an interpretive process about what's happening there, but also enjoying yourself. That could be respite within a certain environment, but it could also be really active play.
If you're enjoying the show, I have a small favor to ask that would mean the world to me. By rating and sharing the podcast, you're helping us grow and spreading our mission of making sustainability really desirable and cool to a wider audience. Besides of that, imagine impressing your colleagues with the latest insights on sustainable architecture. So make sure you follow the podcast and become the most informed in the room. Thank you so much for your support. What do you think about hard edges in coastal cities?
Not a fan.
Why do they even happen?
Yeah, I mean, that's an engineering solution and what we would categorize as gray infrastructure. And at some point, we believed that we wanted to kind of fix that blue line on the map to be what it needs to be. And we've, I would say, consistently failed at that aspect. Certainly, we've seen a lot of things happening in Europe where you're getting these flood walls that are just, getting breached. And again, that's from ranging climate temperatures and increases in rainfall. And we're seeing that in a lot of places as well, I think all around the world. There are some places where you're going to see decreases. The point being is that, those are actually eliminating the ecological gradient that exists in the natural system. So you have this actually produces a series, right, of things that can live at a much wider gradient. If you go vertical, all of those things are going to be the same, right? They're only being adjusting to depth. And we've seen attempts, I think, interestingly enough, to try to mitigate and find places for things to live when we have to go with that vertical condition. But I would hope as well that people start to realize that even if we have to consider the fill situation, which I think was something that we had at one point without knowledge of climate impacts, had said, all right, we got to stop filling in our harbors and bays and developing them. Listen, no more fill in the harbor, right? Boston, San Francisco, I'm sure Amsterdam, they started to say, all right, we got to stop filling in these areas and start to get a better understanding of what our limits are. But they kind of all truncated themselves with this vertical infrastructure. And that, if I look at that from a physics and engineering standpoint, that just increases the energy in the system, right? You're going to crash up against it. That wave's going to get bigger. The next wave's going to come. So that just becomes a destructive system, what we call a high energy system, not where you want to be. Higher the amount of energy between the terrestrial and the marine environment, the less likelihood that things are going to live there. So what we want to do then is consider how we might change that. And I think what we're struggling with in a lot of these places is if we're going to implement what we would call nature-based solutions or green infrastructure to mitigate this, we are going to have to somehow venture within that marine environment and the bottomlands, because we need to actually prepare for the future. Sea level is rising. You can keep on building that wall, but you're never replacing the things that were lost. So the ecological gradient needs to be maintained, because that's where all life is happening, right? It's a very rich transfer between any sort of terrestrial, aquatic, or marine environment. That's where the magic happens. So we need to make sure that we're not like limiting it with that kind of extreme vertical infrastructure, but rather can we figure out ways to rebuild that? And some of that may be figuring out how we actually do go into an environment a little bit further so that we're restoring that gradient. And some of the time we should probably retreat and go back to make sure that that's happening. And those all depend upon a whole series of factors, which is in that ecological soup equation.
That's super interesting. So let's talk about urban cooling strategies. What are some of the strategies you rely on most and why?
So trees are super awesome. Again, let's give it up for the trees. That's going to be the number one because they're doing two things. They're actually transferring heat and energy back up into the environment, and they're starting to cool things down in a way that provides for better efficiency in building systems, and they're providing for subhabitats that exist depending on where you're at, but they're providing again for a really nice way for people to get around in an urban environment without really intense heat. The thing is that we still need to remain cognizant of like soil volumes. People think that they can do amazing things in a very small tree pit, and that just kind of leads to fatalities of those trees. But we've also looked at, how is that occurring at writ large? So you may have some areas of the city that are less densely occupied or may have been former industrial sites. So we have a project that we've been working on in the city of Detroit, which is called the Delray Phytoforest. And that does two things. That really helps to cool overall, because what we're seeing is that like kind of cities work in masses in terms of the amount of heat they're ejecting, and that can actually impact climate and weather patterns that are happening. Some of the listeners may have experienced this. If you live in a really urban area, you kind of look and there's a big storm coming in the summer and it like just goes around you, right? That's urban heat island. So even if you're not living in a certain area, but there's lands that we can start to revegetate, that builds in sequestration into our budget, but it also starts to add in a cooling spot, which may help to mitigate some of those weather patterns that are being impacted as we get towards cities. So there's a lot of really interesting things that way in terms of vegetation, but I'll also go back to green roofs, very critical, right? How those are usually between 1 and 2 degrees cooler than even a roof that's painted white. And then just vertical greening. Anytime we can do that, we're creating this kind of living pillow that's starting to exchange water with its host system, and that's also helping us, again, deal with the stormwater. So holistically thinking about these things, not just as like the one issue, because that may lead you to a different solution. It's a bit of a critique from all of us. I would say a lot of times people and designers and engineers are given they're given the one problem and they go, oh, the secret to flooding is to raise the elevation. True, but that's not the problem, right? You're being asked to serve the thing that's not actually the problem. So holistically thinking about what the other issues might be or the impacts, that's where the critical thinking needs to occur, not in I'm going to solve the one problem and create 20 other problems.
So you think architects or engineers focus, and landscape architects, or we all, even maybe policymakers, focus on the wrong problems or maybe on the symptoms instead of on the problems?
Certainly that is one issue that we often find. And then there's kind of, as I talked about with a rising sea, right? That change in gradient is somehow hard to manage with the policies that you've had in place prior. we're all at fault for being from an era that we didn't understand everything that was happening, and we will continue to be at fault for that. But what we want to do is kind of move on, right? Like try to do better. That's the optimistic part of the message. How can we say, all right, in the 1960s, how we built highways and thought about transportation, like it got us somewhere, but it's not where we need to be now. We need to actually be somewhere else and like try to figure out how we create that change. So I can fault engineers for having that mentality. I could fault landscape architects even for having that mentality. I can fault architects for having that mentality. But the point is that we need to figure out how we start to think about the situations that are at hand, the critical and fragile ecological infrastructures that are actually providing so much for us. We've seen, right, the amount of terrestrial carbon dioxide absorption fall dramatically in 2003 based upon the wildfires, and some say it was net zero. These are things that we should be really aware of and figure out how we can start to influence that. And it's not always like a return to nature. We actually have to believe that we have some agency in how we deal with this, because we now are a significant part of the environmental equation. So how are we going to recycle stormwater for use in the urban environment? Right? That's a good question. I mean, I think we just need people that start asking more questions so that when we start to think about it, right, like, are we going to harvest rainwater from the roofs of the buildings rather than using, like, we've pumped up so much groundwater from the planet Earth that it's now tipping. That's a problem. Like, let's try to figure out, now that we know that that's a problem, let's start to figure out strategies. Like we need to recharge our aquifers. How is it that within the urban environment we start to do those things? Because that's where people are. Even the cities themselves are impacting the balance of how things are happening. So there's a lot of questions that we need to just address up front and realize that's where we're at. And maybe science made that mistake and it was some other impact that actually created that additional tilt to the planet that we didn't need. But right now, this is what we know, and we need to work with what we know, and not believe that it is something that is not true. Right? A lot of people work super hard in the academic realm to give us really good information, and I think there just needs to be that exchange of information when we look to the future.
So not everyone can redesign a park or entire city or even build a green roof, but what are some small everyday changes you think anyone can make to help improve air quality or biodiversity in their neighborhoods?
So there's a lot of cool things I think that you can do on a very small scale. Just get rid of your lawn. I mean, that's kind of a radical thing. If you can't get rid of your whole lawn because it's programmatic and you're like playing catch with your kids and you're using that lawn a lot, like, that's okay. I understand that. Like, you're using that as a sports turf, and that's something that I think is something that's compatible with a human ecological existence. But that lawn, you may want to think of like what that lawn is made out of, because we look at things that are called polylawns, right? They have more than just one species. So you can increase your biodiversity of just your lawn by looking at different polylawn blends that will add in maybe 20%. And then don't like over fertilize your lawn. That's super not good for the waterways. Those polylawns will help you kind of get there because they'll have a mix of things that help to fix nitrogen. And once you do that, then all of a sudden, like, all these cool things are going to happen in your lawn. There's going to be a whole different ecosystem that emerges. Don't put pesticides on your lawn. Let the animals go back and live in that kind of biomatrix that you've created. If you can, like, move to something that's more interesting, like a prairie condition, if you want to still keep it open visually. If you are in a forestal environment, again, try to tune yourself to where you're at. And you can do that at a really small scale. what's a native tree that lives in this environment that would be compatible with what I want to see in my yard? Oh, that would be one way you could do that. I think people are really, you know, I like seeing where people are going with kind of the de-lawning effort and the increase in biodiversity, and that kind of starts with like knowing some really interesting things. So sometimes like just going out into maybe a nature preserve or nature center, whatever is available to you, so that you can kind of experience what the baseline environment and conditions are and find those things that are interesting to you. Find what that is. Everyone's got like such cool things that we didn't have back in the day. You're like, I'm going to take a photo of that and it tells you what plant it is. Like go and try to find out where you can get that plant. And then like start to cultivate your own like micro ecological preserve in a way, the things that relate to you. And what I found with a lot of my residential clients could be, all right, like I want to start an apiary. And I'm like, great, because now we can start to come up with a plant palette that is going to help the bees, but is also really cool for you. And so that might be another goal that's more specific to like what you want to be doing with your free time, if you have some, hopefully, and then start to curate that. I like the microforest movement. It's super awesome. That might be for someone that's like, I just want to see things grow. I don't know what to do with your yard, and that's the Milwaukee method. I don't know if you've heard about that in your other podcasts. So that's really, you start a forest from planting trees about like 2 feet on center, and then competition happens, and it's a way to rapidly regrow a forest, and that helps with carbon sequestration. But you can create little paths in there, and it's just not your normal. I don't know why we've been sold the grass situation here in North America, except for that it's like part of a culture that, it was being maintained by sheep, right? It was being maintained by agricultural activities, but somehow we translated that into this kind of not so productive human ecological system. So I hope that people, even if they need to use it programmatically, there's tools for you. If you don't need it, let's, consider something better.
And what about green roofs? In Switzerland, if you build a new project, you have to build a green roof. And as I told you last time we spoke, I had an episode with Professor Hisham Al-Qadi where we talked about green roofs in Manchester, and he mentioned that insurance companies often refuse to cover these projects because when they are kind of poorly maintained, green roofs turn brown and pose a significant fire risk. So how can we ensure that good solutions like these aren't avoided due to such challenges?
Yeah, and I would say green roofs can be complicated, and that is a collaboration between a landscape architect and an architect and your structural engineer. Because if you want to create like a really rich ecological environment, then you are going to have to add more soils. And we have lightweight soils and other additives, but you're going to have some sort of way that you're accumulating biomass and managing that in a way. You could remove the biomass and then add nutritional supplements. That's one way of doing it. But I think considering like how you might do that structurally is really interesting. We look at things like succulents and sedums that are not going to catch fire, because if they dry out, they still have kind of a gelish-like matrix within their leaf material and within the body of the plant. And that's a really good way that we kind of consider what's happening on that roofscape. For the most part, consider the fact that you need to kind of have enough mass and try to find the right plant material that works with where you're at. Like a roof full of aloes or osmundia, which is a prickly pear, which grows even here, that's not going to start on fire. So what is it that you need to do to make sure that there aren't other things that are coming in from birds and other things that start to make that a habitat? And that to me is one of the most interesting things, that when we leave things alone, like, stuff happens. So climate change is going to impact like a grass roof in a way, which in a way that's also culturally significant to that area. So people have probably lended themselves to look at grasses there. They should probably start to consider other plant material that is not going to have the same impact and is also not going to accumulate grass-like material. So just kind of changing, again, the soils is going to change the impact. Grass wants lots of nutrients. If you're putting too much nutrients up on that green roof, then you're going to find a bunch of crazy stuff up there. So we call that lean soils. So whether that's like gravel and sand and things that are like subsistence living, and when the birds come and they do their bird thing and they poop all over that, that's just adding to that nutrient matrix. So you don't have to fertilize that. They're kind of providing that ecological service. If that's happening on a grass roof, you're going to have a big kind of bloom of vegetal material, and then it will die back because it's kind of having a big party. So you need to find the right material that helps to mitigate that. And I think there's probably some testing that could be done to prove out, like what I've said, for the municipalities. There shouldn't really be a movement against green roofs, because, like, obviously we've taken up valuable ecological real estate in cities, and we need to kind of figure out how we pop that up on top again. For those that can spend a bunch of money, I say, yes, bigger, the better, right? Like, go big. Let's get some trees up there. Let's make it a place that people can hang out and relax and make it a real amenity. And then again, those things have supportive systems, and we would look towards, creating a sort of ecological system, again, human ecological system. So what's the biggest waste of water that we have in the urban environment? It's runoff, because we've created so many impervious surfaces. So when I talk about recycling, runoff, we are at the point now where we have technologies that are going to allow us to capture that stormwater, and then you use it for irrigation, and you use that to build up that ecological structure on the roofs. We even looked at, in some projects, considering how we can capture stormwater for fire suppression within the buildings. So that's what human ecology is. Like, we're going to do what we're going to do, but we can find out how we mitigate the problems that we're creating by actually creating these kind of loops, right? This network of ways that we're also including living things.
Do you know the Busco Verticale in Milan?
Yeah.
Is that something you're talking about?
Yeah. I mean, there's really good examples of people starting to realize how we can create these kind of loops within our own ecology and create these really cool environments. The more we can reuse that water before it's kind of put back into the environment, the better. There's projects like, I would say there's great projects in Europe that look at recycling water more so than we do in the US. And part of that is just, again, not thinking about what we're doing with water. But at the same time, there's really good ways that buildings can reuse water, right? You can use it to flush your toilets. You can use it to, the purple pipe, we call it, right? That's we need to do more of that. And then there are ways that we can use that to create really great things. In Boston, for example, we have a huge metropolitan water district. And if you look at the kind of ecology, the human ecology of what we're doing, I mean, we're drawing water from a reservoir that's, 100 miles away to service the city, but it's all being cleaned by a green infrastructure. Like, they saw this 100 years ago. They knew that this worked. And then, so we're drinking arguably the best water in the United States because it's being cleaned by, sometimes it's New York, sometimes it's Boston, but we're getting that clean water. And because we have this force that's surrounding that. So when that water does fall, it's being cleaned by living systems. And then we're taking that water a little bit on a journey. So when we do that, we want to make sure that we're not wasting that. That then goes to a treatment plant on Deer Island, which is one of the harbor islands. And they take all of the waste that we put into it, and they basically use biodigesters, and then they make fertilizer out of it. And so if you've had a glass of orange juice, probably anywhere in the United States, it's being fertilized from the waste products in Boston. So, I find that super cool, right? That's a cool ecological loop that we can think about. That's what's happening. It's a great fertilizer. It's 11-11-11. And it's something that they really like to use in the orange industry.
That's so cool.
Yeah. So making sure that energy stays in its bucket is really important. Terrestrial, try to keep it terrestrial. Aquatic, try to keep it aquatic. You got a slippage there that we know is going to exist. And that's kind of cool, but can't overdo it. What's happening right now is that the terrestrial environment and all of the nutrients that we're putting on that terrestrial environment are massively impacting the marine and aquatic environments. And it's not great because it's changing that chemistry. And so that's when I say, if you're actually, the scientist that's looking at whether or not we were creating a brown ecology in an aquatic environment or a green ecology, there's a big difference there in how nutrients upcycle. And we're actually kind of controlling that, whether by our urban activities or our agricultural activities. So the more that we can think about projects that are going to influence that balance, the better off we are to protect oceans and the bigger systems. We just kind of lose track. It gets too massive, right?
It does. Scott, this has been so interesting. If our listeners want to hear more about your work and follow what you do, where can they find you?
You can find us at Bishop Land Design. BLD.partners is our website. So you can look at some of the projects that I do that actually start to implement some of these things. And you can also tune in to @BuildPartners, which is our Instagram. I'm on LinkedIn. We have a Bishop Land Design site as well as Scott Bishop. You can find me on there as probably one of the few human ecologists, but also related to Bishop Land Design. And as you know, I work with the American Society of Landscape Architects. I am on the lecture scene and keynote speaker scene, so hopefully some people can see me at those venues. And, I'm just really interested in how we do that. So pull it off. We can do this. We can do it.
That's a cool message. Thank you so much, Scott. I will definitely link all your links in the description of the episode. Thank you so much for joining me.
Awesome. Thank you.
A huge thank you for listening. Make sure you subscribe to the show wherever you listen to the podcast to support me and so you don't miss an episode. And while you're there, I'd also be so grateful if you could rate and review us. If you have any guest suggestions or any feedback, you can find me on the socials @LadinaShipf. Thanks.